So Chapter 6 is our final class on repetition. Up until this point, we've seen uh, while loops and for loops and how they work, how they can be used interchangeably, uh, and how to sort of make the best educated guess as to which one should be used for certain situations. Uh, as you grow as a programmer, you'll see more of how uh, how certain control structures like if statements, if else, if then, if else, if and else, while and for, how those control structures are best used, and which ones are better to be used for what situations. But that being said, this week, as I said, is our third control structure. This week we're talking about methods. Specifically, we're talking about static methods. Conventionally speaking, a method is a behavior of an object, which we'll be talking about later. And you've seen some of this with scanner up until this point, and you've also seen a little bit of it with print and print line. Those are methods of objects. Specifically, the scanner stuff is methods of an object that you have created in order to use in your program, and then system.out.println is an object that is exposed to you from the Java programming environment that you can use for whatever it is you need to accomplish. But in this case, we're talking about something that's a little bit different. What I want to show you guys is something that brings us back a little bit into algebra again. I know that we've talked a little bit about math and algebra and stuff like that, and we haven't really seen anything that is properly related to algebra. But personally, in my opinion, this is following on the same concept. A method can be thought of as a function, sort of like a function in algebra, where you have a particular input or a particular set of inputs that produces some result. It doesn't necessarily have to be a singular result, although in your algebra in your high school you may not have seen functions that can produce more than, let's say, 2 results. Functions in general, depending on what the function is supposed to return, may return a wide variety of results, normally referred to as a set. That's a little off topic. But in this case, I would like to show you how to create a function in a programmatical context. We want to create a method that actually performs the actions of that function. Now, the function that I want to create is 2x plus 1. You all have probably seen this. It's slope of a line intersecting the y-axis at 1, at positive 1, up to over 1, and then up on the y-axis a little bit. But I want to show you what this might look like in order to create this function in terms of a Java context. So the first thing that we need is something called a method header. A method header is simply a way of defining a particular action that we want to have to be repeatable, a particular block of code that we want to have be able to be called on multiple times in our program because we're going to be doing it more than once, let's say. In this case, we are creating our function using this same methodology. And there are pieces that we need to talk about. First off, let's talk about public. One of the things that we'll be talking about in this class, intermingled with everything else that we'll be talking about, is something called visibility modifiers. Visibility modifiers in Java define who can see what in your program. And what I mean by that is you don't care for when people look at your mail, let's say. You know, it may be a private letter, it may be a reminder for a medical appointment or something or what have you, and you don't want people seeing that. So you change the visibility of that letter by having it in an envelope. Either someone sends it to you in an envelope, or it is or you send it out in an envelope. You keep that private. In the same vein, you have, well, in the opposite vein, I should say, you have, let's say, social media, where more often than not, when you post something, unless you have your security settings in a very particular way, it is public to the world. You are not able to hide that really anymore, especially in this day and age. The visibility modifiers in Java are very similar to that. Public, that particular keyword, means that everybody can access that value. In this case, it means that everybody can make use of our function. Now, who is everybody? When I say everybody, I mean that any class or any object in Java can actually make use of this function. There is also a polar opposite to this called private. Private means that function is only accessible in the enclosing class. So that means that only the stuff inside public class main can actually make use of this function that we've created. Okay? That nobody else outside of main can use that function. Period. It is isolated to main, our main class. Okay? But I'm going to switch this back to public for now. In this instance, it really doesn't matter because we're only using one file. Our program doesn't really span multiple files yet, and that's not for a couple of classes. But just know that private and public will start to really level off and be seen about as much as the other as you get further along in programming, specifically when we start building our own classes to create our own objects. The next keyword is static. Static is a modifier that makes it so that you don't have to instantiate an object in order to use that function. Because remember that I said earlier that a regular method is normally associated with an object. And an object needs to be created first before you can use it. Like if you just said scanner.nextInt, this wouldn't work. In fact, it gives you an error. Well, actually, I didn't import scanner. Let me import scanner so I can show you the proper error. Util.scanner. So now the error is proper, and you'll see it here. Non-static method nextInt cannot be referenced from a static context. And all that mumbo jumbo means is that you have to create an object. You have to say something like scanner scan equals new scanner system.in in order to be able to use next int. It cannot be used simply by calling the name of the class. Okay? So static says that all we have to do is call the name of the class to use that function. We don't have to create an object in order for it to be used. And in fact, in this instance, and we'll learn more about this later when we talk about objects, we can't actually create an object of our main class because we don't have something called a constructor here. It just wouldn't work. And we'll talk about constructors later in a different class. The next thing is our return type. Our return type is literally the variable type of the value that this function will spit up. Okay? Conventionally speaking, the only return type that we've seen is this one up here called void. Void just means this method returns nothing. There's nothing that is ever going to come out of this that is useful. Your return type can be any variable type in Java, whether it be a class like scanner, a primitive type like int or double, or anything else that you can pull up. A string. There are other classes called like comparable and print writer, input stream. You can return any of those variable types, but you can only return one particular type at a time. Your return method must return one thing, one variable. Now we'll see some ways that we can circumvent this issue in later classes by using something called arrays and polymorphism, but those are a bit too far down the line for us to be talking about in this class. It's a little bit more complicated than the scope of this particular class. The next thing, obviously, is our method name. In this case, it's some function. Normally, method names are written in camel case format, so the first letter of the first word is always lowercase, and then the first letter of each subsequent word, let's say function in this instance, is always capitalized. It's a really good habit to get into. You'll notice that there are certain things that I do in my programs and the way I format things, and these are more best practice sort of things. It makes your program a little bit easier to read, and following this convention makes it a little bit easier to differentiate between the different pieces of a program that you'll come across. The next thing in the parentheses is our parameters. And we've seen parameters before with our main method, although we've never really used them. Parameters are those things that you pass into methods so that they can do their jobs. Some methods don't require any parameters, and some methods may require in upwards of 10 or 15. There is one library called Apache Commons Math, which provides a whole bunch of hyper advanced math functions that can be done in Java, and some of those methods from those classes and objects are definitely very parameter heavy. But that being said, we only have one parameter for this method. In this case, it's an integer called input. Now notice I didn't set input equal to anything. Okay? You can't actually do this in Java. You can't set a parameter equal to something. That doesn't make any sense. Java won't understand what you're trying to accomplish. In fact, this code right here probably wouldn't compile correctly if we tried to compile it. Yeah, see, we get a whole bunch of mess of red. So don't ever try to set a parameter equal to something. You should always be passing in whatever you want that value to be to the method itself. It should never be equal to anything. Otherwise, your program won't compile. The next thing that we see is our return statement. Now, our return statement is actually where we're doing the work right now. But basically, what return does is it just, if you have a return type, like int, double, string, what have you, your return value is what sends that value out of your method. It is what makes it so that you can produce a value from your method. Okay? Now, that being said, you don't necessarily have to do the work to return something from in the same line that return is on. And what I mean by that is you could create a variable that's called int result and say 2 times input plus 1, and then you could say return result, and that's perfectly legal. There's no problem with doing that. Personally, because of how little is getting done in the actual return statement, I find that this is actually a little bit easier for me to read. I know what is going on there. Personally, it doesn't matter to me. You could do it one way or the other. If you're more comfortable with creating a variable first and then returning that variable, that's fine. But one thing that I would like to mention, and of course I'm alone today, so I can't ask questions and prompt people in the class, but one thing that I would like to mention is that if I'm to put code down underneath here that says, let's say, int some value equals 0, Java will actually give you an error. And that's because that statement is unreachable. Once you call return from inside a method, everything that comes after will never run. So you need to make sure that wherever your code is going to be going, it doesn't hit a return statement first before it gets to completing whatever it's supposed to be working on. Now, that doesn't mean that certain control structures won't still work. So let's look at an example of that really quickly. If I say if input is less than 0, then let's say we want to return 2 times x plus 80. Else we'll return 2 times x plus 1. This is perfectly fine. This will work. In fact, this compiles. Or maybe not. What happened? Oh, I used x instead of input. So this will actually compile. Whoops. Okay, so that compiled fine. This is perfectly fine, and this will run. If the number is less than 0, then this will run. Otherwise, if it's greater than or equal to 0, which more than often than not it probably would be, then this will run. It will run fine. So control statements give you the ability to sort of have multiple return statements, but they have to be based on some condition. You can't just have like you can't have let me set this up here. Let's see. There we go. You can't have this. This doesn't work. But if you use a control statement like an if, a for loop, a while loop, you do have the power of controlling what return statements run when. But that being said, let's fix this. And then what we'll do is let's do a quick demonstration of what it looks like in order to run this method. So we'll do a for loop. For int I equals 0, I is less than 10, I plus plus. And then what we're going to do is we're going to do system.out.println main.sum function I. Okay, so let's compile that. Now, you guys should be familiar with for loops and how they work. You should also be familiar with system.out.println by now. But let's talk about this really quick. So to call our function, what we do is we actually write the class name, which is main, and then a period, and then we call some function and we provide our parameter. Now, if we actually remove this, Java will give us an error and say it requires an int. You have no arguments. You need to actually put in the right number of arguments, otherwise this isn't going to work. So what we'll do is we will put I in here, and then we will recompile. Everything works. So let's see what this looks like when we run it. So we see that it runs through. Obviously, this would be for 0, 2 times 0 plus 1. And then this would be for 1, 2 times 1 plus 1. For 2, 2 times 2 plus 1. Basically, keep going up through the odd numbers is what that function is. So, of course, this sort of waylays me a little bit. I can't ask if people have questions or anything. In a second, I'm going to pause this. Not pause. I'm going to stop this video. We are going to talk about 2 more things. We're going to talk about taking the value from a function and saving it to a variable. And we are also going to talk about, very quickly, modularity. The next video will be fairly short, I suspect, as we go over those 2 pieces.